Today we're going to be talking about similar figures and how we can use proportions to solve for certain parts within similar figures. So first let's talk about similar figures. So when we talk about similar figures, these are two figures that have the same shape, but they are different sizes whose corresponding sides are proportionate. So for example, here we have triangle ABC and triangle DEF. These two have the same shape, but they are clearly different sizes, so we would say that these two are similar, and we would write this as triangle ABC is similar to triangle DEF with the little tilde in between. Now here, the ordering of those letters does matter, just like when we're talking about congruent triangles or congruent figures. And instead of having corresponding parts that are congruent to each other, corresponding parts are going to be in proportion to one another. So for example, AB divided by DE is going to be the same as BC divided by EF, which is the same as AC over DF. All right, take a look at example 1. Find the missing side using proportions. So we see here we have two similar figures, and we're trying to solve for x. Now if these are similar, then we know that we can write a proportion. So we can say that 6 divided by 4 is going to be the same as 12 divided by x. And now all we need to do is cross multiply. So 6 times x is equal to 4 times 12. So 6x equals 48. Divide both sides by 6 and we get x is equal to 8. All right, let's look at example 2. Now this one's a little bit trickier just because we've got two rectangles, but they're not drawn in a way that makes it easy to see that they are in proportion to one another. Imagine that this second rectangle has been drawn on its side. So if we were to rotate it until the shorter side is on the top and bottom, we would be able to more easily see that we have two similar figures. Now, 8 on the first rectangle, DE here, is going to be corresponding to KL, which is 12. So 8 over 12 equals, and then the long side on each of those, so CE corresponds to ML, so 12 over x. And now we can cross multiply and solve. So 8x equals 12 times 12, which is 144. Divide both sides by 8, and we get x is equal to 18. All right, example 3. Now here we're actually solving for a number of missing sides. So let's start with x. So let's find two sides, two corresponding sides that we already have. So KL and QR are both given to us. So 15 over 12 is going to equal, now if we're trying to solve for x to start with, then we can say that this is going to equal x over 10. Now we can solve that, so cross multiply, we have 12x equals 15 times 10, which is 150. Divide both sides by 12, and we get that x is equal to 12.5. All right, next, let's solve for w. So again, we'll use 15 over 12, and now this is going to equal 25 over w. Cross multiply, we have 15w equals 12 times 25, which is equal to 300. Divide both sides by 15, and we get w is equal to 20. All right, lastly, let's solve for y. So again, 15 over 12 is equal to, and now we're solving for y, so this will equal y over the corresponding side on this side, which is 16, so y over 16. Cross multiply, so we have 12 times y equals 15 times 16. So that gives us 12y equals 240. Divide both sides by 12, and we get y is equal to 20. So we solve for x, w, and y. All right, let's look at the next one. Solve for x. We have two triangles ABC and DEF. Now, if you're unsure about which sides corresponds to which, we are given 20 and 15. We're also given 28 and 18, and 24 in x. Now, it kind of looks like maybe one of the triangles has been mirror imaged. So if that's the case, we want to just make sure that we have the same ratio. So if you were to do 20 over 15, simplify that as much as you can, you'd get 4 over 3. And so you want to take 2 of the sides, 1 from each triangle, and also get 4 over 3. In this case, 24 over 18 will also give you 4 over 3. So you can see here that BC corresponds with EF, and AC corresponds with DF. All right, so let's go ahead and write our proportion to solve for x. So 20 over 15 equals, and now we said AC corresponds to DF, so 28 over x. Okay, now let's go ahead and cross multiply. So 20x equals 15 times 28. So 15 times 28 is 420. Divide both sides by 20, and we get that x is equal to 21. All right, we have one last example. Here we can see that one triangle has been flipped over, so it's upside down. We do have the angles marked, so that probably will make it a little bit easier. So we know that the side that says 4 corresponds to the side that says 10. So let's go ahead and solve for x. So 4 over 10, now we have to figure out which side corresponds with x. In this case, note how x is attached to the angle that has 2 markings on it. So the corresponding side on the smaller triangle is the 7, which is also attached to that angle that has the 2 markings on it. So 4 over 10 is equal to 7 over x. We'll cross multiply. We have 4x equals 70. Divide both sides by 4. That gives us x equals 17.5. All right, now let's solve for y. So 4 over 10 equals, well, y corresponds to which side on the other triangle? Well, y on one side has that angle that only has 1 marking. The corresponding side in the smaller triangle would be the side that's labeled 6. So 4 over 10 is going to equal 6 over y. Cross multiply, we have 4y equals 60. Divide both sides by 4, and that gives us y equals 15.